Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the course of geometric design. We are again going to start our introduction on the various factors which are there which affect the geometric design as such. So, let us look at what we have discussed in the previous introduction. In the previous introduction, we talked about the design factors related to users. We looked at the projections of the various stakeholders like population, vehicle population, the land uses, activities, etc. And then we have moved into the road related factors, and the very first thing which we discussed was classification of roads. And then under the traffic volume, two things we have talked about. One was AADT and another was ADT. Now we are going to move forward and let us see that what are the things we are going to cover today. We are going to talk again the rest of the things in the traffic volume, then the traffic composition and its effect, the design period and the design growth rate, the design speed and road capacity. So, these are the factors we are going to discuss one by one in today's interaction. Let us start our interaction with the rest of the factors under traffic volume. Now, we have already talked about AADT and ADT. The next thing which is going to be there is the peak hour traffic. Now, this peak hour traffic is usually considered as 8 to 10% of the traffic in a day. And when you talk about this day's traffic, then we already have ADT in hand, which is on the basis of 3 days or 7 days continuous count. This peak hour traffic is being used for the design purposes of any of the facility, mostly in the urban areas. Then the another factor which is there is design hourly volume, DHV. Now, this DHV can be found out on the basis of one terminology which is written here, that is 30th highest hourly volume, and this 30th highest hourly volume means what? That it is that traffic throughout the year coming from the highest towards the lower side, which is going to be exceeded only for 29 hours in 1 year. Now, when you are looking at this information, then what we are going to do is that we will collect the traffic data for 24 hours in a day and continuously for 365 days in a year, and then we will arrange them in their descending order from the highest to the lowest and try to see that the one particular volume is being exceeded by how many times in a year. And then once this is being created, then we are going to create this graph which is being shown here. On the x axis we have number of hours in 1 year with traffic volume exceeding the shown value, and the value is being shown on y axis. Now, here if you look at, it is being given in terms of the percentage of AADT, it can also be in terms of the absolute values. Both of the ways are good enough to do it. Now, what you see is that the highest value is coming somewhere around 22, but what we are talking is the 30th highest hourly volume. So, here when you look at this 22, which is 22%, we can design a facility for this also. But if we design this facility, then this is going to be utilized only for 1 hour in a year, because this particular traffic is coming only for 1 hour. For rest of the time period, it is the facility, the size which you have created is going to be underutilized, and at the same time you require a lot of money. So, the utilization is one thing which is to be looked, and another is the money required to construct a facility. Now, if you are talking about these, what is being observed is that it is an exponential behavior, and there is a point below which it is going to become more flattening, and it has been found that this is a 30th hour which is there in a year which is going to give you a value somewhere around say 8.5% or 8 to 10%, and that is how we consider that this particular value if we are using is going to be good enough for the design of any facility, and that is what is being defined here. So, in the case of rural highways, it can be considered as 15% of AADT, and in the case of urban roads, it can be considered as 8 to 12% of AADT. So, this is how the DHV can be found out. Now, the another thing which is there is DDHV. Now, here one D is being attached and that is related to the direction. So, it is a directional design hourly volume, that is what we are talking. Now, if you look at the two of the photographs being embedded here, the one photograph on the left and the right, what you can find is on the left hand side it is a normal behavior that amount of traffic which is moving in one direction, more or less the similar amount of traffic may be coming from the other direction also, as you can see that this is the traffic which is moving in these two directions, not much of the difference is there, but yes still if you start counting you may get that difference, it may not be 50-50. But if you look at the another one, what you find is that one side is completely choked and on the other side there are quite few vehicles, and it is something like 95% of the vehicles are travelling in one direction and only 5% are travelling in the other direction. Now, if you look at the first one, this photograph, it means the facility which has been provided here on the basis of the counts on either side is good enough and the vehicles are moving at a desired speeds or at a speed which is interactive but is not low. But when you look at the other side, it is almost a stalled condition, or even if the speeds are there, they may be something like 5 kilometers per hour or 10 kilometers per hour. So, we are trying to look at that what type of facility needs to be provided, and for that reason we go for this DDHV, and this DDHV is calculated as AADT multiplied by two factors K and D, where K is nothing but it is the hourly volume as a proportion of AADT and D is the proportion of traffic in the dominant direction. So, if it is 50-50, that means the traffic moving in either of the direction is equal, then we are going to take D as 50, but if it is like 60-40, the D is going to be taken as 60.6. So, these are the values we are going to consider, and once we have these values we can calculate DDHV. Let us look at this example, where we have been given the average traffic per day as 20,000 vehicles. The traffic in both the direction is being found as 50-50, so it is a ideal condition. The traffic as a percent of AADT is 10%. So, that means we have AADT as here 20,000, K is 0.1 and D is 0.5, and if we multiply all of these things we are going to get DDHV which comes out to be 1000 vehicles per hour. It means now the facility which is to be designed is for this value of 1000 vehicles per hour. Now, the another factor is traffic composition. Now, why we are interested to look at this particular factor? We already talked about a design vehicle, and here also you can see the two things being shown here. One is on the motorized front, where you have a smallest vehicle as a motorcycle and you have the multi-axle truck towards the right lower side which is being shown here. So, you have two units being attached along with the one base unit at the front. So, you can understand that there is a wide difference in the dimensions, there is going to be a wide difference in the space being occupied on a road, there is going to be a difference in terms of speed. So, we have dimension, space occupied and speed, and these things are also being correlated with the performance in terms of their maneuvers. So, say I simply say turning or merging or diverging, any of such thing can be there. On the other front, what you have is a bicycle or cycle rickshaw or e-rickshaw and all those things. Now, when you are going to design, for what particular thing you are going to design is a typical situation and a question, and that is where what we are trying to do is we are trying to make the stream which is having so many percent of cars, trucks, buses, bicycles, cycle rickshaws, etc., into an homogeneous form, and that homogeneous form is being taken as passenger car in the case of urban areas. And when you are trying to convert to passenger car, then this is known as passenger car unit, or in short PCU. What does that mean? This means that if you have a passenger car which is being shown by this, and if you have a bicycle which may be like this, or if you have a truck which may be in this form. So, when they are moving on a road, they are occupying different spaces, they are moving with different speeds, they will not be moving at the same speed unless or until they are following each other, and therefore, what is going to happen is that it impacts the flow properties of any lane or a road. And so, as to account for that, when we try to convert them into a PCU, for an example, if we say the car and the small car is 1.0, that means we are comparing car with a car, obviously it is 1.0, but when you have a big passenger car, then it can be 1.26. Now, here I can give you some idea that how the small car or big car are being talked. They are being talked in terms of the capacity or the CC, that is 1500 CC is being considered as a demarcation between a small car and a big passenger car here. But when you talk about a truck, then it can be equivalent to 3 cars. When you talk about a two-wheeler, it is simply half of a car. Cycle rickshaw, in terms of the maneuverability and all, because of the lower speeds, it can be considered as 1.5 times. Hand carts 3, bullock carts can be 6 to 8 depending on the size. Now, when you talk about these things and it is being given in that form, then they are static values. So, we can use these static values also, which have been given in different codes of Indian Roads Congress for different conditions, maybe mid blocks or intersections, etc. But another can be a dynamic PCU. Now, in this dynamic PCU, the equation which is being shown here, we are trying to compare the projected area of a vehicle with respect to car and the speed of a vehicle with respect to a car. So, we have V, which is the speed, and C is for car and I is for any other vehicle. Similarly, A is a projected area, a plan area in square meters, and then C and I remains the same way. So, if we use this, we are going to get the new values for a traffic stream. So, it means now these are not constant, they will keep changing depending on the changes in the stream. Let us look at this particular example here. We have been given a classified traffic volume, and this traffic volume is being given in vehicles per hour, and we have to find out the traffic volume in PCU per hour. So, the information which is being given is that we have 150 cars, 450 two wheelers motorized, that is WM is wheelers motorized, 15 trucks, 25 buses, 180 auto rickshaws, 180 cycles, and that means if you take a total of this, it comes out to be 1000. And the PCU values are also being defined for this. It means we are not going to find out the dynamic values, the static values are available to us. So, what we have to find it out is the volume in terms of PCU per hour. So, this volume in terms of PCU per hour is nothing but it is going to be a summation of the number of vehicles in a category I multiplied by the PCU of that particular category I. So, if we do that, in the case of car, the PCU factor is 1 only. So, 150 into 1, and that is where we are going to continuously multiply the things, and what we get is 880 PCU per hour. Now, instead of a traffic of 1000 vehicles per hour, what we are getting is 880 PCUs per hour. Now, this can also be understood in a manner that if you have more proportion of smaller vehicles, then the values are going to be reduced than what is you are going to get in terms of vehicles per hour. And if you have the vehicles which are bigger in sizes and their PCUs are also bigger, then there is a possibility that your values will change or increase beyond whatever is being given in terms of vehicles per hour. This is just one indicative condition. Of course, there can be different other conditions also, but this gives you an idea that what is happening on that road. Let us look at another example here. Now, here also we are supposed to calculate the PCU factors, and these PCU factors have to be found out on the basis of the information being given to us, where the plan area is being given in square meters and speeds are being given in kilometers per hour. Now, two vehicles are there for which these PCU factors have to be found out. One is two wheeler motorized, another one is truck, and obviously we are going to compare it with car. So, the data of car is also being given. So, the PCU for two wheeler motorized is going to be what? If you remember that what was the formula? So, it was the formula of a ratio of the speeds versus the ratio of the areas. So, the speed of car versus the speed of two wheeler. So, you have 70 and 60, and the area, plan area of car is 5.75 and for two wheeler motorized is 1.85. If we consider these, then what we get is 0.375 as a PCU factor. Similarly, if we look at for truck, then compared to 70 kilometer per hour, the trucks are moving at 50 kilometers per hour, and the area which they have is there is a mistake here. So, maybe we can look at this because the plan area here is 25. So, this can be 25 and accordingly the values are going to be changed. So, we can also calculate these values and find it out what can be the new value here. So, this is another way of finding out the PCU factors, and you can very easily do it if you have the classified count and as well as you have the speed profiles of different vehicles on a particular road section. So, these are the data which will be required to do this. Now, let us look at the another factor. Now, this another factor is the design period and the growth rate. Now, design period is required because you are going to project the things to a particular year and then you are going to design the facility for that year traffic. So, that is why we require it. So, what you see is that for a categorization of the roads, like in the case of urban areas, arterials and subarterials, and in the case of rural highways like national highways and state highways, it can be taken as 15 to 20 years. But in the case of collector roads and local streets in the urban areas and the district roads and the village roads in the national in the case of your rural highways, then it can be taken as 10 to 15 years period. So, that is a period which usually we are considering and we are going to design for this. So, our facility size is going to be on the basis of this information and the data projected to this. I already said that the peak hour traffic is usually considered in the urban areas. So, that is where the high traffic roads or intersections we are looking at peak hour traffic or 8 to 10% of the daily traffic. When you are working with the two lane two way road, then both directional traffic is considered. When you are working with a divided road section, then the traffic in the busy direction is being considered. That is why we talked about DDHV. And in the case of rural highways, the growth rate is being taken as 6 to 8% per annum, and in the case of commercial vehicles, it is taken as minimum 5%. So, these are the values which are there which can be considered, or if you have the data for your area, then you can use that particular data. It can be in terms of a time series data, whatever is there, you can compute the growth rate there also. Now, the next factor which is there is a design speed. Now, this design speed is going to be one of the most important factor in terms of the design of various facilities, because it is going to impact each and every design. Now, this particular factor when you are looking at and say you have a existing road, then in that case you can find out the speed of the vehicles which are moving on that particular road stretch on different lanes or overall on the whole road. So, when you talk about this particular data and when we try to plot it, so you may have the data which is being plotted in terms of the speed on the x axis and percentage of the vehicles which are going to move on that, and you plot a S curve, and from there if you are going to find out a value as 95th or 98th percentile, then this value is going to be considered as a design speed. In case you do not have that data, you are going to design a new road in a particular area, then some tentative values are already being given by the Indian Roads Congress, and they have been given in different guidelines depending on for what particular type of road we are going to design a facility. Say if we talk about urban roads, for urban roads we can look at IRC 86. We already have talked about the categorization of the urban roads. Now, what you see is that these urban roads, the data in terms of the design speeds, they have been defined for 3 different terrain conditions which are being named as plain, rolling and mountainous and steep. So, mountainous and steep together they have been taken, sometimes you will find they are also being written as hilly together. Here the speed which you can see is that more or less the values are same in the case of arterial roads and subarterial roads, but they are going to be reduced when you go to the lower class of facilities, and in the case of local streets they are in the range of 30 to 20 kilometers per hour. So, we are considering these particular speeds and design the facility, whatever type of facility is required. If we look at on the rural highways, again the speeds are in kilometers per hour. You can look at IRC 73 for that. Here again the terrains have been defined, and now what you see is that all of these terrains have been defined separately for the class of facilities like NS, HS, MDR, ODR and VR. But within a terrain you are finding two values are being given. One is defined as ruling, another one is being defined as minimum. Now, we are going to design basically for this rolling speed, but under the constrained conditions, if it is not possible to go with this rolling speed, then we can go with the minimum speeds being defined. And if you are going to provide the speeds lower than that, then it means the class of the facility which has been created or the functional value which should have been there on that particular facility is not available. So, it is working under a restricted or constrained traffic conditions. This may be due to traffic, this may be even due to some geometric features, this may be even due to the land side developments or their intrusion on the road system. Anything can happen in that direction. So, what you find is that we are usually going to design for a 100 kilometers per hour speed in the case of NH and SH, but for a VR we are going to design for 50 kilometer per hour. And if you look at that, if you try to understand that how these are changing, I am just giving you an idea that these values are going to be replicated in this form, and then they are going to be replicated further here in this way. So, you get the ruling values for a rolling terrain, and then again what you found is that they have been transferred with respect to the minimum values in this form. Now, some changes are going to be there at this front, where plain and rolling is on one side and mountainous and steep are on the other side. Though what you found is that this 50 and 40 are coming, but 35 has reduced to 30, and then when you are looking at this 40 and 30 and 25, and then you get 20, and similarly this 40, 30, 25 goes there, but here there is a change, and then finally the change is there in terms of the minimum values in the steep terrain for the MDR, ODR and VR. Now, in this slide we are talking about the design speed. We already talked about the design speed for the rural highways. Here we can see that the multi-lane highways are being provided, expressways are also there, and along with expressways there is another category which is urban expressways. In the case of multi-lane highways, the plain and rolling terrain and mountainous and steep terrain, these are the two categorizations of the terrain. So, you can find that the two of the terrain classifications have been combined here. In the case of plain and rolling terrain, the rolling speed is 100 kilometers per hour and the minimum speed is 80 kilometers per hour. Whereas, in the case of mountainous and steep terrain, these respective values are 60 and 40 kilometers per hour. In the case of expressways, there are two terrain conditions only. One is plain terrain, another one is a rolling terrain, and in these two cases the values are 120 kilometers per hour and 100 kilometers per hour respectively. Now, urban expressway, which is a new addition, here the classification of the terrain is plain, rolling and mountainous and steep together. That means, we can say that this is a hilly terrain, and in these cases the speeds are being given as 80 kilometers per hour, 70 kilometers per hour or 60 kilometers per hour respectively. If you remember, in the case of arterial roads, we have seen that the speeds were 60, 50 and 40 kilometers per hour respectively. That means, there is an increase of 20 kilometers per hour speed in these cases. Now, the another factor which we are going to talk here is the capacity of a road. Now, what is capacity? If you look again, the two photographs being shown here. In one photograph, it is a national highway condition, you have 3 lanes being provided on either of the side, and this is a divided system. So, a median is being provided in between. So, directional traffic is safe in that form, and at the same time the amount of traffic in terms of the number of vehicles which you can see, and they may be passing this particular point as a reference line at within a particular time frame, is what the volume is going to be there, which is going to move at that, and accordingly we can find out the capacity for this particular system. But here it is working under lesser capacity in terms of the volume which is less than the capacity, and that is why you can find that all of these vehicles are moving at a comfortable speeds, or it may be even the desired speed also. But when you look at the other side, it is a photograph from an urban area, where what you find is lot many lines are there of vehicles, 1, 2, 3, 4, 5, 6, 6 or 7 lines have been created against the number of lanes, which may be something like 3 or 4 only. So, it means the number of vehicles which are going to use this particular facility are quite more as compared to the number of lanes which have been provided, and because the number of lanes are lesser than the number of vehicles which are coming, so it is overflowing, and when it is overflowing there is no lane discipline, and when there is no lane discipline, obviously what is going to happen is, when this is not there, then the speed reduces, and here in this case it is almost a sort of a standstill condition which you can see. That means this is the service is not working as the desired condition. That is the reason where you need to look at the capacity of a road and then see whether the road is working fine or we need to enhance the facility. Now, how it is defined? It is defined as maximum hourly rate. Maximum hourly rate means what? That you are taking the data for one particular hour, and it may keep changing for different hours in a day. So, we are talking about the maximum value which you are going to get in a particular hour in a day, at which the persons or vehicles. So, when you say persons or vehicles, it means it is talking about all type of vehicles, as well as it is talking about the pedestrians, it is talking about the passengers, it is talking about the drivers, everybody is being considered here. They are reasonably expected. Why reasonably expected? It may be that even when you come for the same time on the another day, or on the same day in the next week, you may not get the same values, but it is somewhere very near to what you have got in the previous count. So, that is why it is reasonably expected. We expect that this is going to recur again at this time on the another week also, and it traverses a uniform section of a lane or a point. So, we have a road and we create either this point, or this is a reference line, or we can say that we are going to consider this particular stretch, and we are going to find out the traffic in this stretch. And what we are looking at is that during a given period, usually taken as 1 hour, under prevailing traffic, roadway and control conditions, that means we are talking about a practical condition, we are not talking about a ideal condition here. So, the practical condition, there are so many frictions, and accordingly the capacity is going to reduce with respect to the ideal capacity, and this is being defined as vehicle per hour per lane on a road system. Now, when you talk about this and when you want to compute the value, then this can be done using this formula, C is equals to 1000 into V divided by S, where V is the speed of the traffic stream in kilometer per hour, that is where 1000 converts into meter, and S is the average spacing between vehicles in meters, and that is how you are going to get the vehicles per hour on a particular lane. And if this average spacing is not available, then this can be computed by this formula, or otherwise it can also be considered that if the vehicles are moving at a particular design speed, then they should maintain certain distance between the vehicles, so that there is no collision under the emergent conditions. So, safe stopping side distance which is required at a design speed, if it is available, then that can also be considered so as to use as a value of S. Let us look at the certain factors which are going to make a difference here. So, when you look at factors, the traffic composition is very first thing. As I already said, the traffic composition is going to create an impact in terms of if there are bigger vehicles, they take more of a space. So, it may happen, and they will be moving at a lower speed. So, my graph in this one can be something like this. So, my capacity is reducing. So, this was Q maximum in the normal condition. Now, if this is a graph for heavy vehicles, now my Q has reduced to Q1, which is less than Q maximum. Or there are vehicles which are moving at a speed which is lower than that, then that is also going to create an impact. So, we have to see that what type of traffic composition there is, how it is going to impact the capacity. Another is pavement surface. You can see that this pavement surface is quite good, whereas this pavement surface is not good. So, we can say if it is bad. So, the traffic speeds are going to be, the vehicular speeds are going to be lower, and that is also going to make a difference here. The another case can be a shoulder. You can see that there is no shoulder being provided here. In this case, the shoulder is there, but it is not properly maintained, though it is a kacha shoulder, it is not a paved shoulder, and here what you found is a good paved shoulder. And these are also going to make a difference in terms of the speeds with which the vehicles are going to move and the rest of the things which are going to be associated with that in terms of a traffic speed. The other factor can be longitudinal gradient, and one graph is being shown here. What you can see is that the values are changing from 2% to 6%. Now, as the gradient is increasing, that means this value of I is increasing, the capacity is reducing. It was 1400 and it has become 1000 when you have a 6% gradient. Similarly, if you look at the speed, then the speeds are going down again. It was something like 65 kilometers per hour at a 2% gradient, has become roughly around 47 or 48 kilometers per hour at a gradient of 6%. So, if this is happening, it is again going to make an impact to the capacity of a road. Another case is intersection density. So, you have roads which are like this at different points, and if they are very near to each other, then the speeds cannot be maintained at the same values which we have talked in terms of design speeds, and therefore, this is also going to hamper the capacity. Then the access density means from different locations you are going to provide the access to this main highway, and this is also going to make a difference. Signalization, because the vehicles has to stop at that location and they will again start and move. So, this is also going to make a difference in terms of a capacity of a road, because at some point of a time there is no traffic, at some point there is a traffic which is coming in terms of a platoon, because they have been allowed to move with the green. So, these are various factors which affects the capacity of a road, and we have to take into consideration these while deciding what should be the size of a facility. So, with this we close the interaction today, and we will be talking about the other factors in our next interaction. Till then, thank you and bye.